What's going on? Welcome back to another episode of the Wheel Wednesday Behind the Wheel podcast. And man, today's a good one.
Yeah.
I think I get my jollies off of stuff like this because I'm super technical and I love things that make other things that I don't know how to do possible. Let me explain. Okay. In today's modern day and age with these cars, there is a real problem that exists when you start to do engine swaps, right? Now, there's a lot of other things that we could talk about here that have to do with this very topic. But for me, I think one of the most important things, especially when we start to think about like the cars like, Nick's from Tuning by Nick's, like his 911, right?
Yep.
Has a K series, a turbo K series in there.
Yep.
Crazy swap. And if you've watched any of the other videos that we've done, I've even named it as one of my favorite swaps, K swaps that are out there, right? So the issue when you do any one of these swaps is the idea that you're going to put Honda components, power steering pumps, different, sensors, whatever it may be, into a car that's expecting different sensors and components that came from Porsche. So how do you get these things to speak to each other? Well, in our day, we used to just have to accept the fact that there would be check engine lights or, things that didn't work,
Yep.
Even if you look at a lot of the guys that are doing like MR2 swaps.
Yep.
They do MR2 swaps, but they can't get their gauge clusters to work, right? Now, that may not be a case of CANBUS thing, but what I'm saying is that the idea of doing a swap and making everything work is crazy.
Absolutely.
And, what does this mean for the future of swaps and how potentially, the check engine lights that would appear from basically the car saying, hey, I don't have these things. And as you quell those lights, could you essentially walk your way into basically having an OBD2 compliant car that will operate just like the factory, but have a different engine or powertrain in it, right?
Yeah.
So, that's super exciting.
It is. And the cool thing is that I would love to give you my answer, but there's someone that's here with us, the guest,
Right.
is much more qualified in talking about it than I am. So that's awesome. So
Good thing.
we're actually joined today by William Rori, who is a electrical mechanical engineer. And yeah, William, what's up, man? How are you?
Hey guys, I'm pretty good. Thanks for having me.
Yeah.
Man.
Thank you for joining us.
You're on the right wavelength when your job title is so hard that Rich can't say it with three attempts.
Yeah, my job title is a lot easier to pronounce.
Yeah, it's getting a little bit out of control, but I think that's the longest title I've had and will have. So,
Nice.
All right. Well, we'll get to get you some different certifications so you can put the comma and like.
that's right.
Yeah. So,
Yeah, sounds good.
William, again, thank you for joining us. And as Scott was saying, for CANBUS and all, the project with Nick or whatever it may be.
Well, before we even do that, tell people
Yeah,
like what do you do all day?
it's true.
Okay, so at work,
Right.
what we do,
Okay.
because I want to just be clear, I'm a big motorsports guy, big automotive enthusiast
Yeah.
after work as well. So in work, I work at a pretty cool engineering company, and what we do is a lot of benchmarking. So interestingly enough, a lot of what I do during the day is CAN reverse engineering, right? Seeing how the other manufacturers are doing things. In a lot of cases, we're pulling these powertrains out of these cars and testing them, 20 feet away, right? So we have to fake the cars into thinking that they still have an engine inside, which, 10 years ago, maybe it was a little bit easier than it is now.
Right.
Nowadays, cars literally know, they have GPS. They have different wheel rate sensors. They have, all the adaptive suspension stuff that's doing ride height adjustments. And if anything doesn't jive, it doesn't run right. So
Right.
I basically do what I'm doing with Nick, but on steroids every day.
So now, why would a company want to do this?
Well, so the biggest thing is in the benchmarking world. So mainly I deal with electric vehicles, but that was not always the way.
Okay.
They want to see where they rank. Okay, as far as obviously we're in a big power and range war, right? Every new EV that comes out, you have to have 400 miles range, or everybody just throws you out. Doesn't matter. So they're trying to figure out what these other companies are doing well and what they're not doing well. But the problem is that you can't just I wouldn't say you can't just buy a car from a dealership and drive it around and know how it works, right? You really have to deep dive into it. And so we tear them apart and do, full dimension analysis, metallurgy, But the biggest thing as well is doing the control systems, because obviously you guys know, as we go on, cars are basically just big computers, and so that's kind of the most important part. Your car is only as good as your computer nowadays, as much as that pains me to say. But
no, for sure. So so I want to give my layman version of what CANBUS is, but I think you probably can do it much better. So
let's
what is CANBUS? Let's
Yep. Yeah, so CANBUS is a way, it's basically a communication protocol that was made, let's say 30, 40 years ago. And what it basically is it is a digital 2-wire signal. And effectively, in the easiest way possible, is they have a voltage signal on both those wires. They either go like that, away from each other, or together. Okay, so it's dominant, recessive. Right. And that gets you your 0 and 1. And obviously, your 0 and 1 is how computers operate, everything. Yeah. So what CAN is just a protocol to be able to basically standardize the messages. So there's different message lengths, how they're created, because otherwise it's just random data that no one knows, right? It's just zeros and ones all over. Right. So it's basically a methodology to get everyone on the same page so that no matter what, everyone is using the same thing. And that's important for OBD2, emission stuff, general diagnostics. And so that's kind of why the SAE adopted it, years ago.
Right. And so I think the layman version that I've always heard and always gave me a little bit of clarity from a very layman perspective is that it's kind of like if you were equivalent to like a Wi-Fi network, it's kind of, or to a network, a computer network, it's kind of like the local area network of the car. It kind of does that job of communicating with everything, allowing everything else to communicate back to the vehicle's computer or control systems.
Exactly. And that's pretty much, it's a good way to think about it. CAN's unique because they don't have, it's an open communication system. Mm-hmm. So anyone can listen to anything on the CAN bus and anyone can send anything on the CAN bus. Now, it doesn't mean all the messages will get through correctly, but that's one very interesting thing. Whereas let's say something like Ethernet or USB or any other way of connecting two devices will generally have a handshake between the two devices.
Right.
CAN doesn't have that, which is the biggest advantage because like you said, you can tie a bunch of different components together, which is perfect. That's the perfect use for it. But
go ahead.
I was gonna say it leads it to being able to be reverse engineered on the other hand.
Right. But now the advantage, I don't want to say the advantage, but so when you say reversing CANBUS, what you're really trying to do is you're trying to say, all right, on this line, right? We're trying to intercept the signal of what, let's say, Porsche is expecting and what the sensor or whatever it may be on the Honda engine, in this case, if we do a K-swap into a Porsche, is sending. And what we're trying to do is we're trying to say, all right, this is A for this car, and this is C for this car, and now I want to make sure that it's expecting A, but we're really going to say when you see C, now it's A.
Yeah.
Okay.
Exactly. Yep. And now that's the cool thing. That's why I think that we're actually in a golden day of swaps where you don't have to mess around with changing different sensors and stuff like that. It's all done with a little control board. Way cleaner, obviously easier wiring. So I actually think we're in a good spot for this.
Well, William, I want to say this. I think you're in a good spot for this. For a guy like me, I'm in the wind trying to figure out how to get the damn lights off. But I think what's fantastic is that in theory, and I'm saying in theory because there are a lot of elements to this, but in theory, with a lot of different engine swaps, and there's a lot of rules and regulations and EPA and this and the thing. So I'm taking a lot of that out of the variable situation.
Sure.
But in a lot of situations, when you do an engine swap, the ability to be able to make that car flawlessly have OBD talkback and a lot of the things that the ECUs are going to expect to be able to, let's say, not throw a check engine light when you put something else in, there are going to be the ability to tie these systems together. But if you can essentially put a modern day engine into a modern day car with using the components from one end into another. Again, we're not talking about defeating emissions at all. We're talking about literally just transplanting this one into this one, having it operate on the parameters that this ECU is expecting for the vehicle, but still give you the same output. And again, case in point, the CANBUS that was done between the Porsche 911 and in this case swap that was done into Nick's car.
Yeah, exactly. I mean, in this case, it probably has better emissions and everything. I mean,
Right.
It makes double the power. I would be pretty mind blown without a cat if it did have a full cat and everything like that it wouldn't pass emissions even better than the OE engine. I would bet.
Something that comes to my head is that with me not knowing how in depth this stuff is or how far it goes or whatever it is, the question that comes to my head immediately is that what's the limitations then when you're looking at this type of stuff? Are you going to run into problems with parts from the cars, or is it going to be fully on the person who's doing the engineering on what the limitations can be?
Yeah, so I would say probably the latter. So to break it down, I guess, is my thing. You need to know, in order to get a vehicle to function correctly, all the work has to be done before you even tear the engine out.
Right.
You have to know how the car operates from the get-go, what messages the ECU needs to see from maybe the body control modules or suspension control modules, ABS modules, stuff like that, and then what those modules are expecting back. So really the whole, I would say probably 90% of the work in the CAN reverse engineering realm to make things work is done before you even, pick up a wrench.
Right.
So that's probably the biggest thing. And once you understand at a pretty high level how the car operates beforehand, then you can take out the engine and start really digging into it. And there's obviously a couple methods that we use to make that easier for us. One of them is called gatewaying. So you mentioned OBD2, and so I actually got to I got to make a quick point here. So OBD2 is not actually the CANBUS. Right. While it has CAN lines in it, OBD2 is just a streamed protocol, and it goes through something called a gateway. And the gateway selects what signals and what messages it allows through. It's like a gatekeeper, right?
Sure.
So the beauty of that, though, is that I'm able to plug in, and you can make one from an Arduino, right? You can actually make these things for fairly cheap. You can cut the CAN line, put your module in between, and then you intercept the signals from, let's say this is the ECU and, the rest of the vehicle control modules. You can intercept exactly what's going back and forth. You can modify those signals so you can see what is actually changing, and you can see at what point the car becomes, unhappy, starts to throw check engine light, stuff like that.
Right.
So that's the biggest, I guess, tool I would say I have in my tool belt to actually, start to dig into these cars.
Right. But the interesting part about that is that, the ECU is, while it's dealing with a lot of different components and it's trying to decipher if different systems are running correctly, right? So yep. a lot of that checking and balancing has to do with like for people that don't know, for example, it's checking the evap sensors. It's checking, O2 sensors and making sure that the heater circuit is working. It's checking, making sure it's getting RPM signals and throttle. It's looking for all these things. So we're not talking about changing the tune. That's out of the realm of today's conversation.
Sure.
We're just basically saying, hey, look, if you put a Honda platform in, the messages that are sent maybe through this sensor that are on the Honda engine, the Honda sensor, is not going to be maybe the same as what a Porsche sensor would send. But the sensor is going to work just as well as the Porsche one. So what we're basically saying is you can develop a tie to be able to make this sensor basically output in a box that will translate what it's saying to make the messages match the Porsche. And then it doesn't care which sensor is there. It just wants to know that it's working this way, right?
Exactly. And the beauty of that is, you can modify this instead of having to do old school, signal conditioners to make it seem like it's another signal.
Right.
You can do it. You can take that signal and send it to 5 different ways if you want to. It doesn't matter. You can output it as many different ways. So it actually, in essence, makes wiring a lot easier, I think.
Yeah. And, and I think for a guy like me, and again, here comes the boomer opinion, right? but a guy like me, I think about the things that we had to quell back in the day and what we used to quell with them. Like when you had problems, because you had to be able to, kind of reduce fuel in cars when you didn't have enough fuel control. We hacked masses. We did different things. So then you'd have problems along the way. You throw check engine lights for barometric pressure sensors and stuff like that. So what we would do is we would actually put in potentiometers and try to dial them back to get to the point where it was basically showing what should match at the time. But when you think about that's what we have to do, that's one little tiny area. So now when you see how complicated it would get if you tried to put like a whole swap in with all those sensors? Crazy. Yeah. This is now opening up that whole door.
Exactly.
Yeah.
Yeah.
It's unbelievable.
Sure. Yep.
So now to get into this specifically, you were the one that kind of worked with Nick Rousseau from Tuning by Nick that did that swap. So how does that, I don't want to say, again, we're not looking to give away proprietary information. We're not looking to take away your work, but on a high level, when you start, so a guy like Nick basically pairs up with you and says, hey, listen, man, I'm trying to figure out how to get this, everything that's on this Honda engine, power steering pumps, O2 sensors, map sensors, everything. I want to have everything that's on this Honda, complete engine with all the dressings on it. I want it to work inside my 911, and I want the car to work flawlessly.
Like it came that way from the factory.
Like it came that way from
Right.
the factory.
Yeah.
How do you start? What does he send you? A data log? Where do we start?
Well, so the start was actually funny. So in this case, let me give you guys a little bit of background. So I saw the video, and obviously he has his 911. You guys had him on.
Yeah, of course.
Awesome swap, super
It's
cool.
amazing.
It's so cool. But I saw he bought a Cayman, and now to me, I'm more of a mid-engine guy.
Yep.
They're a little bit cheaper.
Mhm.
They're a little bit lighter. So I was like, man, this is a cool project. And then he was going through it, and I was like, man, the current options for your electronics, first of all, a lot of cases they're not good. They're not optimized. There's one standalone that I don't want to say any names or anything, but it took a long time to get working at even a basic level. So it just wasn't good. So I reached out to them and said, hey, I think we could do this better. I like what you're doing. I think we can do it better. And so basically, I think the first couple interactions is, who's this guy that's reaching out to me?
Right.
Does he know anything? Which is understandable.
Yeah.
And then, basically is trying to get a data log. Does your car run now? If it does, let's start to tap the CANBUS. Just give me a log of you driving, period. Let me see how many messages we're working with. Are we working with 8 messages? And messages are like the folder of CAN signals, if that makes any sense, right? So each message has 64 bits of data that can be sent. Okay, those bits of data, that could be coolant, that could be RPM, that could be some random thing, doesn't matter. So we got to figure out, is there 10 of these or is there 100? If there's 100, we got some work to do, right? If there's 10, which we're kind of in the golden era of cars like this, I would say anything from 1995 to maybe 2015, relatively simple as far as CAN goes.
Golden
Start digging
years.
into it. Yeah, we're in the cars now are in the golden years of doing these swaps and stuff like that. I don't want to spoil anything, but we're getting to the point where it's going to go the opposite way, where it actually gets too much effort to do this reverse engineering to even make it worth it.
Yeah, we have a feeling we know all about that.
I don't want to sidetrack too much, but what you just said on too much effort to make it not worth it for reverse engineering, is that more or less kind of the reason why people wouldn't do more unorthodox kind of made in between platforms and engines? Is just it wouldn't be worth your time?
I think it's a bit of both, right? So I think at the end of the day, while I'm doing this for a passion project, most people are out there to make money, right? So if people don't buy it, in a lot of cases, here let me give an example. Okay, a car that would be much more difficult to reverse engineer, let's say a brand new Cayman GT4. Well, even if we could do a cool swap, which we could, I'm sure, how many people are actually going to put their money down and do it? Right. Probably very minimal. There's a lot more purists there. Those cars don't have engine issues. It's probably not worth the effort, because even digging into it, even knowing what it'll take to get you to the finish line is going to take time. So it's an educated guess is basically the biggest thing. Is anyone going to like this? Am I going to like this? And is it worth the time?
So now when you say, all right, so I'm trying to make this understandable for maybe some people that don't have the experience with actual tuning themselves, right? So when we say the thing about pulling a data log, now to me, you said data log of the CANBUS system, but are we talking about just a general, like if I have the ability to log my car, let's say I have an AEM or a Link ECU or ECU tech or anything that would allow me to data log some of the components on my car, where it just shows you the graphs and kind of gives you the whole feedback. Is that the type of CANBUS, that kind of data log we're looking for? Is it something different?
Yep. Well, so you need both. So like your point, it is really important if you have any level of discrete data. So things that are measured from a pressure sensor, temperature sensor, RPM, wheel speed, stuff that could be in an ECU, just a normal log.
Yep.
That's beautiful. You need that, because really, in essence, what you're doing is you are
Matching
translating
values, right?
this CAN data and matching the value with something that you know.
Mm-hmm.
And if you know that, then you can write it down and then you test it. And then you figure out the scaling and everything like that. And that's basically how you do it. So you need both. You need some discrete data or the ability to test things. Some of the easiest things you could do is just sitting in the car, turning on the headlights, right? Switching switches.
Right.
Generally, you can figure out which bits are changing. And that's how you do that. So to your question, you need both. You need discrete CAN logs. So you actually have to tap into the CAN bus.
Yeah.
Can't do it through OBD2. Or at least you shouldn't assume that you can.
Right.
And then if you have any extra data, that's much needed.
Yep. So let's say, how does a guy like me log CANBUS?
Yep. Well, so it's actually easy. It's actually really easy. So there's so many CAN interfaces that you can buy offline. So you need three things basically.
Okay. You
need a laptop or tablet, something with a USB.
Got it.
You need a CAN interface.
Okay.
Which realistically you can buy those. There's Arduino ones that you can make for like $5.
Meaning just software, right?
It's effectively a software interface, right?
Okay.
So it's like a USB, and generally the USB. It's a USB interface which breaks out into the two CAN wires, basically. Which generally, it's just industry standard that you use like a serial connector, like it's a DB9 is what they're called.
Okay.
So they'll generally plug into your laptop via USB, and then they'll go to like a DB9 connector. And that DB9 connector this is kind of where number 3 comes in. You'll have to splice into it, basically. You have to actually tap into these CAN wires. Unfortunately, you can't go through the OBD2 port. You either have to cut the CAN wire and tee yourself in, or you have to just basically put in like wiretaps.
Okay.
But you have to be very careful though, because CAN is very susceptible to EMI, like interference.
Right.
So it's not a zero risk game as well. So there is better practices to do, but those are effectively the 3 things. Once you have that, all you need to do is turn your car on and hit record, and you will record the raw CAN data that's on that bus.
Now you can start to understand what we're talking about when you say things like how much work is involved.
Yeah.
I mean, you think of all the different things. It's one thing if you have the ability and you're going step by step, right? Like, hey, my gauges don't work, probably is a little bit more complicated than, hey, it's not reading my power steering sensor or my electronic steering rack or something. But like, and here's the thing for people that like, if you want to find out kind of what I mean is, even on a CANBUS car, if you were to swap the dome lights and different things in your car, you'll see ones where it says if you're, like CANBUS approved LEDs or something. And it's because you could put the thing in and all of a sudden the light may flicker, but it also may be solid. And all of a sudden your car is telling you that it's off, or you put a bulb into the, a taillight bulb and it's saying like, hey, like, you don't have it. Like, it's not working, but it's there. And it's very...
One question I have is that when you have when you're doing this kind of engineering and you're trying to have red signals in one direction and the other, or whatever it is it just up to you as the engineer or what the person wants as maybe the owner of the car on like where they care about what, like, to what degree how finished it is, more or less? Like, if it's like, oh, this gauge doesn't work, but I don't care, I just wanted this gauge and the power steering and X, Y, and Z to work and all the real necessities. I mean, can you just stop there, or does it not make sense to do that?
No, exactly. And I think at the end of the day, you really got to figure out what you're trying to do, right?
Okay.
So me and Nick, and even maybe I'm a little bit more OCD than Nick is in a lot of cases. I want everything to work exactly like OEM, but better. We can do, there's a lot of better things, right? So you can do like gauge cluster messages, boost by gear stuff. If you knock, we can do like special messages on the dash, like better than OEM stuff. But in a lot of cases, getting gauges to work, that stuff is easy and you can do it really, really quick. And so it really depends. I mean, in a lot of the cases, the really hard thing is if you're doing these projects, and in this case, Nick is making a kit to sell. But a lot of cases, the people come to you and their engine's already blown up. The car doesn't run, and they want to do some swap afterwards. That's where it's really tough. It's really tough to go backwards from there. You really want a running car first to figure out all this CAN stuff, because that is easy. Because then you can know, okay, when the car is at operating temp, the coolant is going to be around 200. Should be around 200 or so. That gives you a starting point to at least start looking around. That's the biggest thing. So yeah. You got to know. You got to know what the end goal is. If you just want to get the gauges working, probably pretty easy.
So did Nick sit down with this big wiring diagram and basically had to figure out exactly which pinouts that he had from like a body control module that he had to basically tap into or somehow get a reading on to be able to give to you?
Well, so here's the beautiful thing, and this is the best thing about CAN. So you got to realize that in this case for engine swaps, we're only trying to emulate the OEM ECU, right? We're only trying to emulate the engine control unit. So what you do is you would make your gateway connection between the like OEM ECU and all the rest of the components. Every component that has a network is called a node. Okay, it's called a CAN node. But what you want to do is you want to put it in between the ECU and all the rest of the stuff. Because again, at the end of the day, all you're doing is you are trying to replace just the engine controller. So really, all the stuff that you have to worry about are only what that sends and what it receives, which makes things a lot easier because then you're not going around and you're not tapping body control modules. You're not doing all that stuff. You want the body control module to have no idea that you've replaced anything.
Right.
So it can make it quite a bit more simple doing it that way.
So essentially, you're basically just starting at the basically the harness for the ECU.
Just for the ECU, yeah. If we can, I mean, yeah. I don't know if you guys have seen the completed harness up on Nick's site right now. It actually uses the OEM bulkhead connector. The thing is 90% exactly the same as stock. Like we really only used what we needed to connect to the engine. So everything else is 100% the normal wiring, which obviously from a simplicity standpoint is just less room for error, right? Yeah. But then basically it makes it easier on the reverse engineering side because all we had to do is it basically, again, you just connect the OEM ECU connector, you plug it into our box, that box is into our ECU. That's it. So
I think this is like one of the coolest things about what Nick's trying to do and being able to put this package together, because it's going to give people the ability to essentially plug and play and make this car work seamlessly, with this engine, but into a way where, in theory, you could put a stock K-Series engine in, and if you wanted to, you can make this car just as emissions friendly as a more modern day Honda than the Porsche would have ever been, because it's a 997. It's already old.
Yeah, exactly. I mean, I would be pretty surprised. His Carrera 2S came with a 3.8 liter. I'm pretty sure it's much better in emissions.
Yeah,
really.
Yeah.
I mean, I'm just a guess.
Yeah.
So yeah, no, exactly right. It's a big benefit. It's a huge benefit. And the emissions thing is obviously something that comes up a lot. It's asked a lot. I don't know. You guys know Nick's Canadian.
Yeah. Very Canadian.
Yeah, so Canadian, yeah.
Yeah.
So it's pretty hard to navigate the different worlds because we get customers that are like, hey, like, does this work for our specific emissions testing in state X?
Yeah.
And we're like, I don't know, like, maybe. So yeah, that's another layer of work as well, is to get it emissions compliant.
Yeah.
But from the actual tailpipe side, yeah, that's easy. Yeah.
Right. And so that's the next piece of the puzzle, right? Is like the idea that from that OBD2 compliance, I mean, like every state, when they plug into your OBD port, most inspections now in the states that are going to be more concerned about emission controls, they're going to use some sort of plug-in OBD2 test, no sniffer test anymore or anything like that. And those OBD2 tests, the idea is that they're looking for readiness monitors within the computer. It basically is like a checks and balances thing, right? So what it's basically doing is it's saying, hey, like here's the 6 or 7 systems that we're expecting to have working in order. And if these systems are working in order, they're basically going to be in a situation where we know the car from an emissions standpoint is operating like it should and everything should be fine. So they go through OBD2 sensors. There's something there, for O2 sensors. They're checking catalytic converters. They're checking, which is based off a response time between front and rear sensors. They're checking, a whole bunch of different data that it has to do with, evaporative, which ends up being like, is your car have, exhaust leaks, and does it have intake leaks and boost leaks and vacuum leaks and all that stuff. And so essentially what they're doing is they're plugging in to basically check these systems and find out, are they all working properly? They're not, and so if you can get to a point where the system is able to see exactly what these sensors and stuff do, then you could be in an area where you're gonna basically put a car into the ability to pass these inspections. They're just all different.
Yeah, and one quick point on that, and I guess I don't want to get Nick, Link, or anybody else in trouble, but the Link ECU is capable of doing the O2 the readiness checks, right? So OBD2 still works. We haven't tried it because, again, like I live in Michigan. Michigan's no emissions, no checks, nothing.
God bless Michigan.
Yeah. So and there's goods and bads. Exactly. So that actually it has a potential, and again, we don't want to advertise this stuff because it's just such a, like, you guys know how the tuning thing works. I mean, there's diesel companies that are getting shut down 24/7. You just don't want to mess with emissions too much. It's really tough.
Yeah.
But it technically can do it.
But that's the one pathway. I mean, and I don't want to spend too much time on this one piece because I think it's extremely hard to balance this out. And I don't want to, I know people go into the Scott's a boomer thing with this whole thing, but the reason that I always get so annoyed at this whole EPA thing, and I think people get super struck with this, is it has nothing to do with the EPA putting restrictions or limitations and trying to reduce the carbon footprint. Like, That's not where my aggravation is. My aggravation is the fact that there is no other pathway except to say no, because the technology is so much better than it has ever been before, and we have the access to do things completely legally, and I would even say in majority of situations, we have the ability to make automotive and all cars perform better than they came with from the factory. But because we're not given a viable pathway forward to do these things and have people that are approved to do these things, we're putting ourselves in a situation where we're basically just saying, no, you can't do this. And that's so blind, and it just doesn't make any sense. But I guess that's my frustration with all this stuff.
Yeah, no, I agree. I don't know if it's necessarily a boomer opinion, but I really truly they're pricing people out of it. For some reason or another, our company does emissions testing, like legitimate EPA emissions testing for EVs as well. The cost to get a car emission certified is incredible. I mean, absolutely incredible. So I don't know whether it's, like you said, there is no extra pathway except for big bucks, which unfortunately that cuts out a lot of the things. And, that cuts out a lot of, different transmission options. By the way, they have to get you, if you have a manual, which I love manuals, absolute die for them, you have to get emissions testing on it. Different, even same engine, doesn't matter. You still have to go through the cycles and all that stuff. So it's becoming very expensive to do anything except the simplest. And then you wonder why. And again, I calibrate EVs for a living.
Right.
There's a big push from not only just from the consumer side. They're easy. They're cheap. They're cheap to make from the OEM side. There's no emissions. They're easy. They're literally easy. So yeah.
It's wild. Listen, I appreciate all the time that you spent on this one. I don't want to. We could go on for I could literally talk about this stuff for days. But
wait, before you wrap up, I want to make one point too.
Yeah.
But no, we're good on time. But what's it called? Scott probably didn't see this, but there was
You're not gonna boomer me.
No. We put out a podcast clip that made it out to our TikTok or whatever, and it was a clip of Scott talking about how, through his time he learned on how certain parts on cars, you figure out what works with what and what doesn't work with what or whatever it may be.
Yeah.
So on that reel that we put out
Okay.
on TikTok, like it got some traction. And it's because a lot of people in the comments were just saying,
Hating on me?
yeah.
Yeah.
And they were just they were just saying like this guy just spent a minute just trying to say you can just tune your car or whatever it may be.
That wasn't it at all.
So that's not the point. So, that's the way everyone took it. But like, this is a great example on how, when you talk about getting parts to work together, whatever it may be, goes beyond just tuning.
Yeah.
And that's very surface level to what people interpreted it to.
You know what?
For
Because
sure.
we've created a bolt-on generation.
Exactly.
That only that God forbid they
Yeah,
were
yeah.
sent a turbo kit and didn't have copper crush washers.
Yes.
They would melt and they'd be like, I got to return the whole kit.
So I
Gotta return
knew
it.
that you probably didn't see all those comments.
I guess not.
But every comment basically said, dude just said tune your car in 150
But it's
words.
It's not and that's listen. There's a difference between a tuning. It doesn't matter. Oh man, now you got me
little
rifled
fire
up.
You got it
But
heated.
listen, there's a huge difference between tuning your car and putting a turbo on your car.
Yep.
That in the power band that you're expecting to have power, that turbo is remotely efficient in. I'm sorry, you cannot out-tune that. Yeah. You can change the part there. You can try to make it better, but you're never going to make a turbo change its efficiency map just because you're unhappy. Like, it's just, I'm sorry. Like, for all those that are stuck in La La Land, the remote tuning can't do certain mechanical things. If you take your mechanical timing, I'm ramping now. You take your mechanical timing, right, on an engine, and you somehow set it improperly, right?
Yep.
Like, you can't just tune your way back to success because the mechanical timing is there. You could change the ignition timing. You can change variable control timing. You could do all that stuff, but the car is expecting it to be at a mechanical base timing of set as a certain way as a base. So like the fact that we go into talking about parts, you can't just magically tune everything. You have to start with a mechanical base. Listen, I'm sure. Listen, I want to have
Almost got here.
Yeah.
No, I know, but you can
Sorry.
see why
I lost it. I blacked out.
you can see why I brought that up, William.
Yeah,
because-
he's looking for a clip
yeah.
out. Jerk. Listen, this is the part that gets me. It's here. I am so for car people and car enthusiasts that it's absolutely ridiculous. I love the fact that I get to be at the helm of this company because of the opportunity that allows us to keep doing cool car things. Like, and these guys will speak about this over and over. Like, when I leave here, I think about cars. Like, before I go to bed, I always check Facebook Marketplace. I'm obsessed with cars. Like, I just want to do cool car things. But with that means that you have to take the responsibility once you get into modifying your vehicle to at least put the effort in to understand what you're doing. Now, listen, if you take the approach that you're going to be happy with this different thing and you're going to drop your car off and you're going to have an authorized professional tune your car, that's fine. I'm good with that. You know what I mean? You're still in the book. But when you try to give people lectures about what they can tune and what they can't tune, and then you bring your car to somebody and you say, hey, tune to this number, you're blind. That's not how tuning works. You tune a car to where it's at an appropriate happiness. And that's where you stop. Like, to tune to a number, there's things you can do to try to tweak it, but like, that's just a backwards way of thinking. Anyhow, so I'm done ranting.
You hurt a lot of feelings there, Scott.
Listen, here the thing is, like, I feel like I just got baited by Rich. He saved it right for the end. But listen, I think that the conversation we had here is so cool. I would, if you don't mind, I would like to maybe have you come back at some point and do another podcast relation to kind of EV tuning, because I think it's a really cool thing. One, I think you do it every day. But two, I think that there's going to be a level of, tuning that will be available at some point for EVs. And people have heard me, and just so we're clear, for all your Cybertruck loving people out there that think that I'm against anything EV, I'm not against EV. I'm against somebody pushing an agenda that EVs should be taking over the world because they're going to drastically fix our emissions problems, right? There's an easier way to get there without disturbing everyone along the way, and we could do it way faster. That's my issue. I'm not going to go into it, but I would love to have you come back on and talk about, for the people that are into EVs already, big Tesla people,
I
whatever
would
it may
definitely
be.
have some questions about that. So
Yeah. How these tuning modifications could work to make this car more performance oriented, better, etc. Would you be down for that?
Of course, and I can probably talk even longer about that.
Good.
That's the next level above CAN, right? I mean, so
Yeah.
again, it's the next tuning level of where do we go from here, right? We're here right now. Stuff is still able to be tuned. Where do we go from here?
Right. That's sick. We're going to make sure that next time Rich doesn't hit me with any clips that will incite the media, incite the internet, and I'm going to have to deal with all these people flaming me in the comments.
Yep.
Yeah. So thanks for hanging out with us.
Yeah.
Thanks for having me.
Yeah, we're going to have you back because I'm super pumped about that whole other thing, and that would be kind of dope to see and kind of hear, because I legitimately really don't know too much more than some of the aftermarket based stuff that's happened.
Yeah,
so
but
far.
in the time that we're in with automotive, there's so many questions and unknowns with EV that I think everyone would want to know some answers. So
Exactly right.
for
yeah.
sure.
But yeah, William, thank you so much for joining us, man.
Yeah, dude.
Thanks for having me. Looking forward to it.
We really appreciate it. Thank you so much.
Yep. Take care, guys.